Hey, welcome back. So we have a brand new section with a new data structure called the hash table, also known pretty commonly as a hash map. So these are used so frequently, you've probably used them all the time, I certainly have, because they're built in to pretty much every programming language out there, whether we're talking about JavaScript or Python or Ruby or Java, just Scala. Pretty much every language has a variation of a hash table or hash map built in as a default type. So you don't have to do anything. Just like with an array, most languages have a built-in array or list type, and you can just use it out of the box. So we will be implementing our own version. We will make our own, but just like with an array, you're probably in 99.999% of the cases going to want to use the built-in array class or list class or whatever similar structure there is. There's no reason to reinvent the wheel. Same with the hash table. But there's a lot of really cool stuff for us to talk about as to how they work, what hashing is. I should actually just talk about that on this slide. So in this section, we're going to explain what a hash table is. That will be in this video. Then, 2 for 1 there. We'll define what a hashing algorithm is. Define what a hashing algorithm. Oh boy, these slides, that's not ideal. So define what a hashing algorithm is. Discuss what makes a good hashing algorithm. There are certain characteristics we're looking for. Then we'll talk about what happens when collisions occur in a hash table, what that means for there to be a collision, and then 2 strategies for handling them, something called separate chaining and another thing called linear probing. Those sound like 2 different methods of torture. So we'll get there, but let's start by just discussing what a hash table is. So as I already mentioned, these are all over the place. You've probably used them in whatever programming language you prefer. Hash tables are used to store key value pairs. And yes, so are arrays. Arrays associate a key, like 0 or 1 or 2 or 3, to a value, which could be anything else, but those are strictly numeric. Hash tables are not. And on top of that, the keys in a hash table are not ordered. So in an array, of course, the indices start from 0 and they go up to some number, they keep going. There's a specific implicit order. Hash tables, that's not the case. And another cool thing about hash tables is that they are fast for finding values, for adding new values, for removing values. It's all fast. So we'll talk about why that is and how it works. But first, let's go into more detail on just why you should care. So as I mentioned, pretty much every language out there has some sort of hash table structure. Because of their speed, they're used really commonly, and they're also just data itself often lends itself to being stored this way. Yeah, if you have sequential data, great, you could use an array. If everything has an order and there's a number that makes sense to associate it with a position, use an array. But a lot of the time, our data may not fit that pattern, so we could use a hash map or a hash table. So here's just a quick overview from certain languages. These are what their implementations of hash maps or hash tables are known as. So Python has a dictionary or dict. JavaScript has objects and maps. And I did put an asterisk here because in objects, you actually are only allowed to use strings as keys, but it's the same idea. Behind the scenes, it's implemented basically as a hash table. Java, Go, and Scala have something called a map or maps. Ruby, they didn't even bother. It's just called a hash. So these all are key value data stores, and they implement hash tables. So hash tables are sort of a generic idea, and you could implement them in many ways. Dictionaries in Python, maps and objects in JavaScript, maps in Java, Go, blah, blah, blah. Okay, so let's pretend that those disappear. We're not able to use the basic built-in JavaScript objects or Python dictionaries. If we still want a key value data store, we need to implement our own. So that's what we're going to do. Imagine they just mysteriously disappear. How would we write our own version of a key value pair hash table, a data store? So imagine we want to store some colors. We're making a website. We have color codes, hexadecimals, which are really difficult to keep track of or to differentiate between. So we could just store them in a list like this. But this, there's an order here that's implicit, but there's no reason that we'd want to store them in a particular order. It doesn't matter. I don't know which color this is, what color that is. You get the point, hopefully. This is not a great way of storing colors unless we just need a random color at any point. That would work. If we're just picking something random out of here, great. But if we need particular colors at a particular moment, it's not great. It's not readable. What do these colors correspond to? So rather than using indices or numbers to access the colors, it would be much better to use, human readable keys like pink, which this is pink, or a version, one type of pink. Orange red might be, or it is this color. Cyan, this color. This would be much better if I could just say, give me colors of pink or colors of cyan, which, here we go. Colors of cyan is much better than colors 2. So we're going to try and implement this structure on our own. Even though, of course, in JavaScript and Python, you would just be able to do this out of the box. But if we didn't have access to dictionaries or objects or maps, how would we do this? So that's what this section is focused on. I think it's kind of fun because we get to go into some fun detail onto what hashing is, what hashing functions are. We're going to talk a little bit about some math, get into prime number land, discuss how prime numbers play a role in this. It's all sort of fun stuff. So that's our goal, reinvent this basic mapping, key value pairs.